Hello everyone, this is Math 111Z, and this is section 3.1 in your text, and this is quadratics and their graph. So fun and easy, you guys are gonna love it. All right, so let's just start with the general form of a quadratic is f of x or y, you could write that as y, is equal to ax squared plus bx plus c. And where the domain of this function is all real numbers.
Wait, did we already do this issue?
Yeah, you did this last year in Algebra 2.
Okay.
Yeah. All right, so, and you can complete the square. And when you complete the square, you get something called vertex form. And that would end up with a times x minus some number h squared plus k, where h and k is your vertex, and a determines your stretch, your vertical stretch.
I remember this. This is easy.
Yeah. When I graph these, what I like to do is know that y equals x squared, like the very base family. If you put a 0 in, you get 0 out. If you put 1 in, you get 1 out. If you put 2 in, you get 4 out. If you put 3 in, you get 9 out. If you put -1 in, you get 1 out. If you put -2 in, you get 4 out. If you put -3 in, you get 9 out. So if I am graphing this, and it is y equals a x minus h squared plus k, from the vertex, go over 1 up a, go over 2, now this here 2 is 4, go up 4 times a, go over 3 from the vertex, go up 9 times a. And then this is both to the right and left. So if you go over -1, you still go up a. If you go over from the vertex, -2, go up 4 times a. If you go over -3, then you go up 9 times a. This makes it super easy to graph these. Let me show you how. Let's say I want to graph the following equation. -2 x minus 1 squared plus 3. So that's the equation I'm about ready to graph. As I start graphing this, we know my vertex is going to be 1, 3. The opposite of this and this, right? So I'm going to go 1, 3. That's messy. Sorry. I didn't want it on the middle because I want to see more of the graph. I go over 1, up 3. There's my vertex. Now this says, from my vertex, go over 1, up a, but a is negative, so I'm going to go down 2. And I'm going to go back 1 and down 2. And so that was my first step. And then for my second step, I'm going to go over 2 from my vertex. Let me show you with a different color on my pen. Over 1, 2 from my vertex. And then I'm going to go down 4 times a. 2 squared times a. So I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. and that's gonna be my next point right here. These are symmetric around your axis of symmetry, so which is your line through the vertex. So this would be 1, 2, and down 8 again, right there. And now I just connect these lines together. Usually 5 points is plenty to graph.
So if that equation wasn't squared,
It would be -4, or, no, -4, positive 4.
If it wasn't squared, it'd just be a line.
I mean,
It'd be
where was that-
constant.
Where you have your third point down, way down there. it
Right
would
here?
just go- Because the square root of 2 is 4. If that equation wasn't squared, it'd just be 4, right? I don't know.
I think I understand what you're saying. If I didn't have this 2 here, then it would just be 4.
Yeah.
It is 8 because I had this 2 here, so I'm taking 2 times 4. All right, let's do another one. We'll do one without. So let's do y equals, oh, that was not the right pen. Y equals x minus 2 squared minus 1. All right, so my vertex here is 2 comma negative 1. Then I take the opposite of what's here and then what's here. Because the formula is x minus h squared plus k. Right. So I get that. So I'm going to go over to 2, 1. I'm going to again offset my axis a little bit so I can see more of my graph. So I'm going to go over 2, up 1, right here. Except for, I'm going to go down 1. Over 2, it's a negative 1 for my vertex. Over 2, down 1. Right there. All right, this just has nothing here. It's an A is 1. So A equals 1. So I just go over 1 from here, up 1. Over 1, up 1. Then I go over 2 from my vertex, 1, 2, up 4. Then I go over 2, up 4. And then I can draw that baby out. I could keep going if I want. I can go over 3, up 9. 5, 6, 7, 8, 9. Over 3, up 9.
What? Wait,
And there we go.
what about that -2 there?
That's part of the vertex.
Oh, yeah.
Okay.
So it doesn't, you don't use that in yours.
Nope, it's always, because you're counting from the vertex. So for graphing, that's the easiest way to graph this.
Didn't we do something similar last section?
Similar, yes.
So why wouldn't the graphing of this be, or when you wrote the problem, why wouldn't it be x parentheses squared and then -2 parentheses squared?
Because that's not how you write it in standard form. All right, let me move things from general form to standard form and back and forth, and let's see how that works. So that is the next thing anyway. Let's take this f of x equals 3x squared plus 12x plus 8. We're going to rewrite it in vertex form, and then go and then go from there. So this is called general form in your textbook. That could be a point of confusion for some people. This is called general form, and what I am calling vertex form, which literally everybody calls it vertex form, your textbook is calling standard form. So I'm going to move from general form to vertex form. All right, so how do I do that? I need to complete the square. But notice that when we complete this square, first thing I'm gonna do is I'm gonna take this 3 out. Everybody okay with that part? Now I'm gonna complete the square inside the parentheses. Completing the square is easiest to do when you have no number in front of the x squared. So I'm gonna ignore the 3 because it's not inside the parentheses. Yes?
Could you take the 3x out?
No, you can't. We want the x there so we can complete the square. We need it to be squared.
Oh, yeah.
Yeah. So I'm gonna take this, I'm gonna take half of the 4x, which is 2, and I'm gonna square it. 2 squared is 4. I'm gonna add 4, and then I'm gonna take away 4, because you can't just add 4 to something and make it the same. That's similar to adding 4 to both sides of the equation. Okay. And now I'm gonna complete the square of that part right there. That's the part that I made squared. So 3 is gonna hang out here, and then inside here I'm gonna have x plus 2 squared. This, if I FOIL out, equals that. Minus, there's still 4 here, plus 8. Now, I'm gonna multiply my 3 into here and distribute it. So I have 3 times x plus 2 squared minus 12 plus 8. So this would be 3 times x plus 2 squared minus 4. So I have a vertex at -2, comma, -4. And I have a stretch of 3. So if I wanted to graph that, I go -2, -4, put a dot right there. Okay. And now, from here, from my vertex, I would go over 1, up 3, because that's my value. Over 1, up 3. Over 2, anybody know how many up I have to go?
3 times 4, so it'd be 12.
Exactly. So I'd go up 1, 2, 3, 4, 5, 6, 7, 8. Or 4, sorry. 8, 9, 10, 11, 12. I can't count to 12 apparently. 9, 10, 11, 12, which is at 8, which is what I was thinking when I said that. Over 2, up 12. And now I'm going to connect these lines together.
Question.
Yes.
In the above one where you put, when you complete your square,
Uh-huh.
you put the +4 and the -4 both.
Inside the parentheses.
So is that the more efficient way? Because before we were taught to put put a +4 on that side and then just put a +4 on the other side.
So because this 3 is here, I can't just put a +4 without multiplying it by the 3, because I'm actually multiplying this by 12.
So if you were to do the other way, it would be much more because you'd have to put a negative.
I'd have to figure out how to put, I'd have to put a +12 on the other side and then subtract it over to the other side. So there is a way that, like, if that bothers you, let me do one more example and I'll show you a way that you can get around that.
It makes sense. That's new because
I'm gonna show you like 3 more ways to get around completing the square, but I'm gonna show you this one way of completing the square that you'll get around it nicely. Let's say I had 3x squared minus 5x minus 2. Okay, this is a nice one to do because it's not very pretty at all. Because 3 and 5 are not factors of each other, right?
yeah.
So it's not a pretty one. So one thing I could do is I could go ahead and move the 2 over to this side. So I have this. And then I can divide everything by 3 on both sides. I'm going to unravel this later, but for now I can do that. And I'd have x squared minus 5/3 x. And then I can complete the square. So if I complete the square,
Thirds x
I'm gonna, half of this would be 5/6 squared would be 25/36. So I can add 25/36 to both sides.
Oh my goodness.
Wait, how'd you get
Square, so you
half?
factor it down to,
Half of 5/3 squared is
Oh,
25/6,
half of 5/3.
or 25/36. And now I'm gonna square it, just leaving this thing over here. Now I'm gonna square both sides, or do the square, sorry. And that would look like that. Now I have to unravel and solve for y on the other side, right?
this is my
So
drawing.
I would subtract the 25/36 from both sides again. And then here's this piece where I have to multiply everything by 3.
You forgot your 3 on the.
I didn't. Oh, sorry. It just didn't write, sorry. Now I'm multiplying this by 3 because I have to multiply everything on both sides by 3. So that makes this 25/12. And then I subtract 2 from both sides. So y equals 2 is the same as 24/12. So this would be 3x minus 5/6 squared, and this would be minus 49/12. So that's what that would look like. That's an ugly one just because the fractions don't work out beautifully. But you can, like, if you don't want to mess with the parentheses, you can push everything on the other side and then unravel it again on the other side. But there's actually even an easier way to complete the square. Ready for this? All right, so we know from lots of different things that the x part of the vertex is minus b over 2a. The x part of the vertex is minus b over 2a.
Is that in all quadratics?
In every quadratic, ax squared plus bx plus c, the axis of symmetry, is minus b over 2a,
So,
right?
oh yeah, that makes sense.
Okay. And I can prove that to you if you'd like. Let's take a quick look at the proof of that.
Well, yeah, if you have the B and the A, then
Yeah,
it'd be pretty easy to find the X, because you have only one thing to solve for.
Right. So basically, you prove this by the same way you prove the quadratic formula. You complete the square with this stuff. So if I complete the square, I pull the a out. Right? And I take half of that and square it and add it inside the parentheses. This is going to be b squared over 4a squared. You're going to see a lot of pieces, 4a squared. You're going to see a lot, 4ac, you're going to see a lot of pieces here that pop up in the quadratic formula because this is the same way you prove the quadratic formula. So now I take this and I can't just add something without subtracting it. That's my bad. Sorry. Let's erase that for a minute. Let's add and subtract it. Now I'm going to complete this square. It's going to be x plus, and this is the square root of this, which would be b over 2a squared. And then minus the b squared over 4a squared, and plus c. All right, so if I simplify that one more time, this would be x plus b over 2a. I'm going to multiply this a in, it's going to cancel out one of those, and this is going to be b squared over 4a plus c, because I multiply that a in and it canceled one of those out.
Negative b squared divided by 4ac.
Right? And now if I'm looking for a common denominator here, I get a times x plus b over 2a squared minus, and this is going to be b squared. Again, I'm looking for a common denominator, so I'm going to multiply this side by 4a times 4a, and that's going to be plus 4ac, and this is going to be all over 4a, right? You can see what's going to happen for solving this, the quadratic formula is you push that over there, you take the square root from here, and that gives you your square root of b squared minus 4ac, so on. But notice right here, and this is the key thing that we're looking at, is our vertex is this. This is our vertex, the opposite of this, which is minus b over 2a.
And then the other numbers too.
And then this would be the h value right here. But nobody ever remembers the h value because usually you just find the x value and you can find the h value by plugging it into the equation. So, so nobody ever memorizes that. Everybody memorizes this. That the x part of the vertex, or the axis of symmetry, is x equals minus b over 2a. Right? So how does that help me with completing the square? Let's take the first one we did. Again, this one right here. I had 3x squared, oh goodness, 3x squared plus 12x plus 8. So minus b over 2a is just negative 2, right? That's my x part of my vertex. And then I can figure out h pretty easy by plugging the negative 2 back into here. 3 times negative 2 squared plus 12 times negative 2 plus 8. So this is 3 times 4 plus negative 24 plus 8. So 12 plus negative 24 plus 8, which is negative 4, right? So now I have my negative 2, and did I do that math right? I think I did. Yeah. And negative 4. That's my h and my k. This is my x, and this is this is my h, and this is my k. So if I plug that back into my form, also my a is always whatever is numbers in front of the x squared. There's my a. I don't even have to complete the square. If I find my vertex, I can just go y equals 3, x minus h, so plus 2 squared, plus k. I don't even need to complete the square at all. I can just find my vertex and plug in the numbers into the form.
Wait, so I need to rewind this because I was
Okay.
taking notes, and when I take notes, I don't
Let's do another example.
follow the actual learn part. So
Let's do another example. Let's say I want to, say the job is to write this in vertex form, right? I can complete the square. That's one option. But my other option is to just find the vertex. So minus b over 2a, which is 8 over 4, which is 2. So my axis of symmetry is x equals 2. Now, I plug this 2 into here. So I get 2 times 4 minus 16 plus 1, which is 8 minus 16 plus 1, which is negative 8 plus 1, which is negative 7.
okay.
So now my vertex is 2 comma negative 7. Now I can just take that vertex and this a right here that's in front of my x squared, because the a doesn't change from form to form. The a is always the same. So y equals 2 x minus 2 squared minus 7. And that would be my, so I didn't need to complete the square. I can just find the vertex and go that way.
Why is it, -2 in there? Oh,
Because it's the opposite of whatever you have here.
so shouldn't it be
In your
plus
vertex.
7?
It's only opposite for the x and not for the y. It's okay. The form, like the form is y equals, and here's an interesting x minus h squared plus k. But it really is the opposite of the k, Sam, because look, if you were to write this as you would in old times, you would write it like this, like that, and see how the k is affecting the y, and it's the opposite, and the h is affecting that, and it's the opposite. But we are moving the k to the other side, so it's not the opposite. Does that make sense?
So
Okay.
I need to flip the 2, but you don't wanna flip the 7.
Exactly.
Okay.
Good?
Yeah.